Hello everyone, my name is Atinoke Fasia. Welcome to your InterswitchSPAK prep class. I'll be your chemistry tutor. So today we'll be looking at organic chemistry. Organic chemistry is a study of carbon-containing compounds as the chemistry of carbon-12, together with few other elements like hydrogen, oxygen, sulfur, and the halogens. Carbon is the most important element in the study of organic chemistry, and it is unique in some different ways. Let's look at the ways in which organic carbon is unique. One, it forms single, double, or triple covalent bonds between its own atoms, a phenomenon called catenation. It can form long bonds, single bonds with itself and other elements. That's catenation. Carbon atom uses its 4 valence electrons. Here's its tetravalent. So it uses the 4 valence electrons to form covalent bonds with non-metals or metals that is bonds with. It exhibits isomerism. Yes, carbon can exhibit isomerism. Isomerism is a phenomenon whereby compounds or organic compounds will have the same general molecular formula but different structures. Carbon atoms in a molecule may form a various chain as in hexane, branched as in 2-methylpentane, and they also form rings, cyclohexane or in benzene. They have electronic configuration of 1s2, 2s2, 2p2, which allows it to form 3 types of hybridization. Hybridization, we have sp3 as we can find in alkanes, we have sp2 as we can find in alkenes, and sp as we can find in alkynes. I'm sure all these are not new to you, so let's see other reactions, other things about organic compounds. They are covalent because they are made up of non-metals. Carbon is mainly a non-metal, so they are covalent. So most of them they exist are gases and liquids, and the force of attraction between them is van der Waals. They are non-polar in nature, and they do not have opposites and negative, positive and negative sides. They are soluble in water. They dissolve in non-polar solvents like benzene. They have low melting and boiling points. They are thermally unstable. They are flammable and bonds isothermically to form camophorous oxide and water. Their reactions are slower than that of inorganic chemistry. Inorganic chemistry reactions are faster, but organic compounds, organic reactions are a little bit slower. And they have definite shapes. That's why we can say that tetrahedra or any other shape that they form. Let's quickly look at functional groups. I'm sure you've done all these in school. It's just like a brief reminder before we look at some questions on them. Functional groups is a bond or an atom or group of atoms that gives an organic compound its characteristic chemical properties. We have homologous series. This represents a group of compounds with the same functional group. We have alkanes, alkenes, alkynes, alkanoic acid, alkanoids. They all have families, and these families have some properties that they follow. One, each family has their own general molecular same general molecular formula. So for alkanes, they have CnH2n plus 2, alkene CnH2n, and so on and so forth. Then each member of a particular family differ by CH2, or you say R relative molecular mass of 14. The physical properties changes based on their increasing molar mass, because as they are going down the group, they are getting bigger, and a lot of physical properties changes as you go down a particular series. They have similar chemical properties, not same but similar chemical properties, and they are prepared the same way. These are characteristics of homologous series. Organic compound is split into 2. We have one side which is hydrocarbon. We have the other side non-hydrocarbon. Hold on. We have hydrocarbons. We have non-hydrocarbons. We have hydrocarbons are compounds, organic compounds that have or that consist of carbon and hydrogen only. But non-hydrocarbons are organic compounds that have both, apart from carbon and hydrogen, they have other elements attached to it. The other hydrocarbons, we have aliphatic, which could either be branched or straight chain. and we have aromatic, that's the likes of benzene, toluene. Then we have under aliphatic, we have cyclic, and we also have acyclic. Cyclic could be cyclopropane, cyclobutane, acyclic are straight chains. Then under acyclic, we can split it into two. We have the saturated and we have the unsaturated compounds. Saturated are organic compounds that have carbon single bonds in between them. Their carbon-carbon bonds are single. While unsaturated are organic compounds that they are carbon-carbon bonds, they have multiple carbon-carbon bonds. It could be double or triple. And for saturated, under it can be split furthermore into two: alkanes, cycloalkanes. Then unsaturated we have alkynes and alkenes. Now let's quickly look at isomerism. I said that they exhibit isomerism, and we have two types of it. Mainly, we have structural, we have stereoisomerism. That's arrangement in space. Another structural, we could have chain, functional, or positional. So it depends on the functional group, depends on the position too. Then we also have under stereoisomerism, we have geometrical and optical. Structural isomerisms are compounds with the same molecular formula but different arrangement of constituent atoms or different structures. So you see a compound having the same molecular formula but exhibiting different structures. You can withdraw different structures of it. That's isomerism. And also we have geometrical isomerism. It's the existence of compounds with same molecular formula but are not identical because of different special arrangement of the compound atoms. It is mainly common in alkenes. Let's see examples of geometrical isomerism. Now let's look at this compound. We have two compounds there. Let's use the arrow. We have excuse me, let's go back. Okay. We have two compounds there. We have butene. If you look at this properly, you realize that we have the CH3. There are four carbons. 1, 2, 3, 4. And the double bond is on the second carbon. That's 1, 2. Then this is the double bond. Now, the other carbons are arranged in a way that they are on the same plane. And that's why you call it 6-butene. While you look at this, you realize that the other carbon are arranged adjacent to each other. And that's why they call them trans-butene. Okay. Now, this is another example. This is dichloroethane. There's two carbon, and there's chlorine attached to the first carbon, chlorine is attached to the second carbon. Then for every carbon you must have 4 bonds, so that's why you have hydrogen there. Now, the chlorine are adjacent to each other, that's why it's trans. And here you realize that the chlorine are on the same plane, that's why it's cis. Let's quickly look at 3 main organic homologous series: the alkanes, the alkenes, and the alkynes. Let's quickly look at it. So we're starting with alkanes. This aliphatic hydrocarbon with general molecular formula of CnH2n plus 2. They are very stable compounds, and all valence electrons are used up in bonding. They are saturated, and the first 4 members are gases at room temperature, while the next 16 members are liquid, and then the higher ones are semi-solids or solids. Methane is a major example and is the first member of the family. Formula CH4. It is a major constituent of natural gas and is also given off from swamps and marsh gas. We could also see methane in rice paddying area because it's also seen where we have organic matter being decomposed. These are sources of methane. Laboratory preparation of methane. It is prepared by reacting soda lime. That's a mixture of quick lime and conc sodium hydroxide with sodium ethanoate. The soda lime is used because it is non-deliquescent like caustic soda and so does not attack glass so readily. As you can see in this reaction, the sodium ethanoate plus sodium hydroxide will give you methane plus sodium triacylcarbonate 4. And like we said, that one of the characteristics of homologous series is that they have the same general method of preparation. So the same way that methane is being produced, ethane is also produced the same way. Another preparation of methane is action of water on aluminum carbide, as we can see in this reaction. Now this is a diagram for the preparation of methane. We have the diagram for the preparation of methane. That's sodium ethanoate plus soda lime. You boil, and your methane is produced, collected upwardly. Physical properties of methane. It's colorless, odorless, slightly soluble in water, but soluble in organic compounds. It's less dense than air. No action on litmus. That means it doesn't change blue litmus paper red and red litmus paper blue. The melting point increases as the molecular size increases. You know this. You need to note this. The melting point and the boiling point increases as their molecular size increases, because as alkane molecules become bigger, the attractive forces between the alkane molecules increases. This is not really peculiar only to alkanes. Is with other homologous series. As you go down the series, their RMM, relative molecular mass, get bigger, and this leads to a lot of things for them. We'll be seeing some questions that will come later on. Then the density and flammability increases as well, because they have more carbon, so they become more dense and they can become more flammable. Chemical properties of alkanes. 1. Combustion. All organic compounds can combust. You burn them in air, excess air to produce carbon dioxide and water, in limited air to produce CO and water. That's carbon dioxide and water. One major reaction that alkanes undergo is substitution reaction, otherwise known, for this particular reaction, otherwise known as chlorination, halogenation, or you say photochemical reaction. And that's the reaction of methane plus chlorine in the presence of sunlight or ultraviolet rays to give you chloromethane. The hydrogen air will have to be substituted. All hydrogen will have to be substituted, and that's what you see in the first reaction, the second reaction, the third reaction, until here you have the tetrachloromethane, that you see that all hydrogen has been substituted. Now let's read this. Substitution reaction involves the direct displacement of an atom or group by another atom or group. Alkanes are generally unreactive compared to alkanes. So alkanes undergo substitution. That is a major reaction that alkanes undergo. Now, quickly let's look at the uses of alkanes. It's a good source of fuel, used in the industrial preparation of hydrogen, used in the preparation of other chemicals such as carbon sulfide, alkynes, trichloromethane, and tetrachloromethane, and organic solvents. So that's all about alkanes. Moving on to alkenes, formula CnH2n. It has the presence of a double bond. They have a general molecular formula CnH2n, the double bond in between them, which makes them unsaturated. They are chemically more reactive and more active than the alkanes. So they burn more luminous, they burn with smoky flame, they burn more, and they are produced by dehydrating of alkanones. Alkenes are produced by dehydrating of alkanones. As you can see on this slide, when you remove water in an alcohol, you are expected to have an alkene. So you use a dehydrating agent. A very good example is concentrated tetrasulfate 6, which acts as a dehydrating agent. Industrially, it is produced by catalytic. Ethane is a major example to be used in alkenes, and industrially it is produced by catalytic cracking, thermal or catalytic cracking of fuel oil fraction from petroleum. When we have after fractional distillation, then you have cracking to break down the larger hydrocarbons to more effective use of either petrol to have more petrol, So in the catalytic cracking, you have long chain molecules being split down, or broken down, cracked. For example, we have octane in this slide. Octane C8H18. C8H18 being broken down in the presence of heat, pressure, and catalyst of aluminium oxide to produce ethane and ethene, which is used as fuel. It said earlier that ethene are produced in the laboratory or prepared in the laboratory by dehydrating ethanol in the presence of concentrated tetrasulfate 6 at 175 degrees C. This involves removing elements of water from an ethanol in this example to give you ethane. The reaction is of two stages. The first is the ethanoic acid, the H2SO4 reacts with ethanol to give you ethyl hydrogen tetrasulfate 6, as you can see, ethyl hydrogen tetrasulfate 6, and the ethyl hydrogen tetrasulfate 6 breaks down to give ethene and sulfuric acid. This is the preparation of ethene. The diagram for the preparation, where we have the dehydrating agent, which contains H2SO4, reacts dehydrating ethanol in the presence of it to produce ethene. Sodium hydroxide is used to remove gaseous impurities such as sulfur 4 oxide, carbon 4 oxide, and ethene is collected over water. Physical properties of ethene is a colorless gas with a faint sweet smell, no action on litmus, slightly less dense than air, and is only sparingly soluble in water. And we have the chemical properties of ethene. Like I said earlier, all organic compounds can undergo combustion. Excess air will give you CO2 and water. Limited air will give you CO and water. What major reactions that ethene undergoes? If you can remember, I said that alkanes undergo substitution, alkenes undergo addition reaction. This involves the direct addition of an attacking reagent across the double or triple bond of an unsaturated compound to yield a saturated product, or at least one in which the degree of saturation is increased. So by the time alkenes go into reaction, they lose one of their bonds, become saturated. This is like a flow chart on the reactions that ethene undergoes. Ethene undergoes combustion to give water and CO2. Ethene undergoes hydrogenation in the presence of nickel as catalyst to give ethene. Ethene undergoes halogenation, that's adding halogens to ethene, either chlorine or bromine, but in this case we use chlorine as an example to give us 1,2-dichloroethane. Like I said earlier, that when ethene undergoes reaction, they lose one of their bonds. So we have 1,2-dichloroethane. They undergo oxidation to give ethane 1,2-diol. They undergo hydration. If you can remember, the dehydration of ethanol will result in ethene. Now, hydration of ethene will give us ethanol. So that's a reversible reaction. Then ethene will react with bromine water and it decolonizes. That is a major test to differentiate ethene from ethane. So ethene reacts with bromine water and it decolorizes. Ethene undergoes polymerization. And when it undergoes polymerization, polyethylene is formed. Polyethylene is formed. Uses of ethane is used for ripening fruits, used in the production of organic compounds such as epoxyethane, ethanoic acid, is the raw material in production of polyethylene, polyvinyl chloride, that's your PVC, polystyrene, is in the production of artificial rubber, also in dibromoethane, a petrol additive. Now this is a test. Bromine water test is a test to differentiate alkanes from alkene. In alkane, bromine water, which is reddish brown in color, do not change. No change. But in alkene, it decolorizes it. It decolorizes. So this is test for saturation and unsaturation. Now let's quickly look at alkynes. Like I said, we're going to look at alkanes and alkynes. Then we'll look at some questions on the organic chemistry generally. So looking at alkynes, looking at alkynes, we realize that the general molecular formula is CnH2n minus 2. CnH2n minus 2. CnH2n minus 2. And the first member of the family is ethyne. That's the first member of the family, ethyne. That's C2H2. The structure, it has triple bond in between their carbon-carbon bond. It has triple bond between them. They are saturated hydrocarbon in which there exists a triple bond, and they are very reactive. They are more reactive than the alkenes and the alkanes. They are more reactive because they have higher degree of unsaturation. You know, they have triple bonds, so they are more reactive than alkenes that have double bond, and alkenes are more reactive than alkanes that have only single bond. They are prepared by adding cold water to calcium dicarbide, as you can see in this reaction. Prepared calcium carbide plus water will give you calcium hydroxide and ethyne. And this is the diagram for the preparation of ethyne. The calcium carbide with sand, then put your tissue furnace there, and the ethyne is produced. This removes impurities. That's acidified copper sulfate, removes impurity, and your ethyne is produced. Physical properties of alkynes. It's a colorless gas with a characteristic sweet smell when pure, slightly soluble in water but readily soluble in propanone. Propanone is an organic solvent, slightly less dense than air, is unstable and may explode on compression to a liquid. Yes, as I've said before, all organic compounds undergo combustion. You can see ethyne undergoing combustion to produce carbon dioxide and water. Because it's a triple bond, multiple bond, it undergoes addition reaction. It undergoes addition reaction, and the way it undergoes addition reaction, it reacts till all the triple bonds goes away. So for example, alkynes will react first stage to give an alkene, then react second stage to give an alkene. That is how alkenes react. So for example, you can see in this illustration, this is an alkyne, which is ethyne, reacting with, let's say, AB. The first stage yields an alkene. You can see it has lost one of the bonds there, and that is why you have the bond split into two. One goes there, one goes there, and your AB split into two. So A comes to the first carbon, and B comes to the second carbon. So further reaction will yield an alkene. Further reaction, you can see that all the multiple bonds have disappeared. So it becomes saturated. So unsaturation becomes saturated. This is a flow chart to show the reactions of ethane. Ethane undergoes combustion to give water and carbon dioxide. It undergoes hydrogenation to give ethane. It undergoes halogenation to give 1,2-dichloro 1,1. This is 1,1,2,2 tetrachloroethane. Then it undergoes oxidation to give ethane dioic acid, undergoes polymerization to give you a benzene, and it undergoes substitution reaction, terminal alkynes, which now differentiates ethane from ethane. You know, we've already said that alkanes from ethane, you use bromine water to dechlorize to know the change. So it decolorizes bromine water. Alkanes do not decolorize bromine water. But to differentiate an ethane from ethane, you add copper 1 chloride or silver triazonitrate 5, and these are the products. So we have substitution. This is a substitution reactions. Only terminal alkynes undergo substitution reactions with this compound. Now, terminal alkynes are alkynes that their triple bonds are at the end of the compound. So if you have pentyne, that means the triple bond is either at the terminal, at the end, or with the first carbon. Then these are the compounds that can undergo substitution reactions. But ethane undergoes both addition and substitution reaction. Uses of ethane is used in ethane flame, a very hot flame used by welders for cutting and welding metals, used as fuel in lamps, used in the production of polychloroethane, a plastic, also in neoprene and artificial rubber, and so on and so forth. Now it's time for questions. Quickly get your writing materials and let's see how far we can go with these questions. Now, like I always do, what you need to do, I'll give you some time to pen your answer. Then you see the answer after a few seconds. Then you mark yourself to be sure that you got it right. So let's see how far you can go. Relax and get ready for the questions. Yippee! The following are saturated hydrocarbons, except we have mentioned saturated and unsaturated. So which one is saturated and which one is not? So let's see which one is not saturated. Butane. Yes, butane is the answer. Methane, pentane, and propane are saturated hydrocarbons. Saturated hydrocarbons which have single bond between their carbon atoms in the hydrocarbon chain. For example, we have the alkane. And unsaturated hydrocarbons are hydrocarbons in which there's a double or triple bond between any adjacent carbon atoms. We have alkenes and alkynes. Next question. The occurrence of two or more compounds with the same molecular formula but with different structures is called, is it isomerism, is it allotropy, isotopy, or deliquescence? And the answer is isomerism. That's the answer. Isomerism is the answer. Oh, sorry. Before we go to the next question, let's quickly look at that. Carbon atoms within a molecule can be arranged in two or more different ways, which is called isomerism, and is the existence of two or more compounds known as isomer with the same molecular formula but different molecular structures. So the next question. Which of the following is not a petroleum fraction? Yes, which is not a petroleum fraction? Is it diesel, kerosene, chlorine, or naphtha? Answer. The answer is chlorine. Now let's look at fractional distillation of crude oil. Okay, this is fractional distillation of crude oil. which we have our natural gases, followed by naphtha, kerosene. Naphtha is used for petrol, kerosene for jet fuel. We have gas oils for diesel, heavy oils, and you also have your lubricating oil, which is mainly from bitumen. You can also have bitumen, which is used in making or tarring of roads. So this is a reminder of fractional distillation of crude oil. So chlorine is not a petroleum fraction at all. Chlorine is not a petroleum fraction. Which of these hydrocarbons has the highest boiling point? Which one has the highest boiling point? Okay, your answer? Ethane. Yes, ethane has the highest boiling point. And why does ethane have the highest boiling point? From this question, you will realize that ethane formula C6H14 is bigger than other compounds there. Methane is CH4, pentane is C5H12. Oh, we have two pentane. So, but the answer is ethane. Yeah. Melting and boiling point increases as their molecular size increases, because as alkane molecules become bigger, the attractive forces between alkane molecule increases. The process by which larger molecules are converted into smaller molecules under high temperature and pressure is called, write your answer down, is a subjective, you should be able to get the answer. The answer is cracking. The answer is cracking. Yes, cracking is when we have larger molecules broken down into smaller molecules at high temperature and pressure. Now, this is an example of cracking. Here we have that's heptane broken down to ethane and pentane, and we also have the diagram of cracking here. So this is known as cracking. Alkene, we undergo the following reactions except. Alkene, we undergo the following reactions except. We have combustion, we have substitution, addition, or polymerization. So which one will alkene not undergo? So we have our answer, substitution. Alkene undergoes combustion, alkenes undergo addition, they undergo polymerization, but they do not undergo substitution. Okay. Oh, sorry. What's the IUPAC name of this compound? As you can see in this structure, let me see. I think I have this structure drawn. So let's see the structure. Okay. If you look at the structure, you realize we have 4 carbons, 1, 2, 3, 4, which are represented this way. So the first carbon has 2 hydrogens, then you Cl. Then the second carbon has 2 hydrogens, Then we have CH. Okay, what's the IUPAC name of this compound? Let's look at it. The IUPAC is 1,3-dichlorobutane. And how do you get 1,3-dichlorobutane? If you look at it, you realize that we have 4 carbons. So we have 4 carbons, and then we have 1 chlorine attached to the first carbon, also attached to the third carbon. That's 1,3-di, because there are 2 chlorobutane. Which of the following hydrocarbon is unsaturated? Which one is unsaturated? From the option, we have our answer to be ethane. Ethane is unsaturated. All other compounds there are saturated. Saturated hydrocarbons contain only single covalent bonds, while unsaturated hydrocarbon contains at least one or more double or triple carbon-carbon bonds. Which of the following hydrocarbons will not undergo addition reaction? So which one do you think will not undergo addition reaction? Now, so what's the answer? Now, looking at the options we have, we realize that the answer is pentane. Pentane will not undergo addition reaction because it's an alkane, and alkanes do not undergo addition reactions. Others will undergo addition reaction because of the presence of unsaturation in them. They have a double bond or triple bond in them. The hydrocarbons mainly used as domestic and industrial fuels are, so which one among the options are used as domestic and industrial fuel? And the right answer is alkane. Alkanes are used as, they are good source of fuel. They are good source of fuel, and they are used to prepare other compounds, other elements like hydrogen, carbon 4, trichloromethane, which is also known as chloroform, and tetrachloromethane, an organic solvent. The process by which alkene is converted to alkane is called, one name is given to that reaction. Reaction by which alkene is converted to alkane. If you can remember what we have said earlier, the answer is hydrogenation. Hydrogenation is a process by which alkenes are converted to alkanes. In the presence of nickel, we have a reaction of ethene reacting with hydrogen to give ethane. Ethene reacting with hydrogen to give ethane. The following gases decolorize bromine water, except bromine water is used to distinguish between alkanes and alkenes. So which one will not decolorize bromine water? So if you look at it very well, our answer should be B, methane. Methane will not decolorize bromine water. Bromine water is used to differentiate between alkenes and alkynes. Alkanes will not change, while alkanes will be decolorized. Ripening of fruit is hastened by using. Now, if you look at your option, which of them is used in ripening of fruits? Fruits, which one is used in ripening of fruit? The answer is ethene. Ethene is used in ripening of fruits, and it has a lot of uses. One of the major uses that is used in ripening fruit is also used to produce organic compounds such as epoxyethane, ethanoic acid, ethane 1,2-diol. It's also a raw material in the production of polyethylene, polyvinyl chloride, polystyrene, artificial rubber, 1,2-dibromoethane, and which is a petrol additive. Organic molecules that have the suffix YNA are unsaturated hydrocarbons that have a single bond, a double bond, or a triple bond. So if you look at options very well, the answer is a triple bond. Yes, organic molecules that ends with YNA have triple bonds. How many carbon atoms are there in 2,3-dimethylhexane? 2,3-dimethylhexane. Let's look at it. In our option, the right answer is 8. But why is it 8? Let's see the structure of 2,3-dimethylhexane. Hexane is 6 carbon, so we have 6 carbon drawn. And methyl is attached to the second and the third carbon. So how many carbons can you count? If you count 1, 2, 3, 4, 5, 6, 7, 8. Our answer is 8. Which of the following gases will diffuse faster when passed through a porous plug? Diffusion has to do with the lightest, how light a species or element, a compound is. So if you look at the options carefully, which one do you think is the lightest? How do you do that to calculate the relative molecular mass of each? And the lightest one should be methane. That's 16. If you look at others, they are much more bigger than methane. So one of the factors to consider in diffusion is the mass of the gas. The mass of the gas. Which of the following is the principal constituent of natural gas? If you had listened carefully, you realize that we measured it in the previous in this lesson. We mentioned in this lesson, and the answer is methane. Methane is a principal constituent of natural gas. Okay, moving on to the next question. What amount of hydrogen will be required for the complete hydrogenation of 1 mole of butane with 1 ion? Now, how do you do that? Quickly guess, or you should be able to get the right answer, because I had earlier mentioned that when butanes react, or when alkynes react, they do it in 2 different stages. They first give you an alkene, then they now give you an alkane. So the answer should be 2 moles of hydrogen. Now, let's see the reaction. You see that in this reaction, ethane will first react with hydrogen to give you ethane, then ethene will react further to give ethane. This is the same also for butane. Butane will react with hydrogen to give you butene. The butene will also react with hydrogen to give butane. That's C4H10. Which of the following reagents can conveniently confirm the presence of a triple bond? Now, I was also mentioned earlier that for you to confirm or to differentiate an alkene from an alkyne, you can use either ammoniacal silver triazonitrate 5 or copper 1 chloride. So your answer is copper 1 chloride. These 2 reagents can be used to differentiate triple bond from double bond. Ammoniacal silver triazonitrate 5 and copper 1 chloride. Both of them can be used to differentiate triple bonds. Alkenes do not undergo this reaction. Only alkynes undergo this reaction. What is the geometry of methane? What's the geometry of methane? Is it octahedral, hexagonal, pyramidal, or tetrahedral? The answer is tetrahedral. The shape of methane is tetrahedral. Now, seeing that structure, the shape of methane is tetrahedral. I hope you are marking, I hope you are trying to take notes, and I hope you are gaining a lot. The product of reaction between propane and hydrogen chloride is, so I need you to write the reaction. Propane is C3H6 reacting with HCl. What do you think the answer will be before I show you the answer? Okay. The answer is CH3, CHCl, CH3. Yes, that is the answer. Let's see in this reaction. So we have ethane reacting with hydrogen chloride to give you 2-chloropropane. 2-chloropropane. Which of the following is an aliphatic unsaturated hydrocarbon? Aliphatic unsaturated hydrocarbon. The question has really shown what we are looking at. Definitely is not option D. Option D is eliminated because it is not an hydrocarbon. Now, the other 3 are unsaturated, but which one is aliphatic? Aliphatic are straight chains and they're not cyclic. They are straight chains or branch chains. So the answer here is butene. The answer is butene. Butene is aliphatic unsaturated hydrocarbon in the option there. Aliphatic compounds, an organic compound containing carbon and hydrogen joined together in straight chains, branch chains, or non-aromatic rings. It is one of two broad classes of hydrocarbons, another being aromatic compounds. Benzene and toluene in this question are aromatic compounds. Now, complete this. So we have CXHY, 8 oxygen to give 5,4 oxide plus 6 water. The hydrocarbon CXHY is the reaction above is. If you look at the product side, you realize that we have 5 carbons on the product side. So definitely your X will be 5. And if you look at it properly, you also realize the hydrogen is 12. That's 6 times 2. So your Y2 will be 12, and that will be C5H12. So which of the series is that? That's an alkane with the formula, general molecular formula CnH2n plus 2. So the answer is pentane. That is our answer. Pentane is C5H12. Which of the following is an undesirable paraffin in petrol industry? Which is an undesirable? Undesirable that is not wanted, we don't want it. Paraffin in petroleum industry. The answer is, did you get it? N-heptane. That's the answer. 2,2,4-trimethylpentane is actually a desirable one. Is a desirable one because the quality of petrol is measured according to octane number, and it depends on the average composition of branch chains to a straight chain alkanes like normal heptane hydrocarbon in the fuel. Petrol containing higher percentage of straight chain hydrocarbons like the N-heptane, they have rating close to 0. They causes more knocking than that containing higher percentage of branch chain hydrocarbons, which is close to 100. An organic compound that decolorizes bromine water is said to be saturated or unsaturated. That is very easy. The one that decolorizes bromine water is said to be unsaturated. Oh, this is fast, so you've seen the answer. What is the molar mass of alkene with the formula CXH8? H is equal to 1, C is equal to 12. Now, how did you get 56? That is the next step to look at. You realize that your CXH8 is equivalent to saying, because an alkene, so a CXH8 is equal to CnH2n. Where your S is equivalent to N and 8 is equal to 2N. So N is equal to 8 over 2, which is 4. That's C4H8. And by the time you calculate the molar mass, that will be 12 times 4 plus 8 times 1, which is 48 plus 8. Then the answer is 56 grams. The product of catalytic hydrogenation of propene is A. Propyne, B. Propane, C. Propene, D. Propanol. So when you have hydrogen to propene, in the presence of nickel, what do you get? The answer is propane. That's the catalytic hydrogenation of propene is propane. That is the reaction there. Propene plus hydrogen to give propane. Which of the following compounds has the molecular formula C5H10? That is very straightforward and very easy. The answer is pentene. Pentene, it has C5H10 as the molecular formula. Pentine will be C5H8, while pentane is C5H12. Which of these hydrocarbons has the lowest boiling point. The one that is small or smallest out of them, we have the lowest boiling point, and the answer will be propane. Propane, we have the lowest boiling point. If we consider the relative molecular mass of each one, propane, we have the smallest value. Ethene plus hydrogen to give ethane. The reaction represented above is called, what is the name of the reaction represented above? The answer should be hydrogenation. That's ethene plus hydrogen in the presence of nickel as catalyst will give you ethane. Which of these hydrocarbon is used in the production of styrene? Yes, styrene is one of the products formed during polymerization. So, and the only compound that exhibits or undergo polymerization in this reaction, in this question, is ethene. Ethene undergoes polymerization at high pressure, overheated catalyst and pressure to give you polyethene. Which of the following is not a type of isomerism? So which one is not a type of isomerism? We have geometrical, optical, functional, and spiral. The answer is spiral. Spiral is not a type of isomerism. As you can see in this structure, in this diagram, isomerism, these are the different branches of isomerism that we have, and spiral is not part of them. Give the name of the final product of the reaction between methane and chlorine in the presence of ultraviolet light. This is a subjective question. So what is the answer? Now the answer will be tetrachloromethane. Earlier in this lesson, we have looked at substitution reaction of alkanes, whereby we said the reaction cannot react except in the presence of sunlight, and these are the different stages to the reaction. All hydrogens will be replaced or substituted. The first reaction will give chloromethane, the second one will give you dichloromethane, the third one trichloromethane, while the last one will give you tetrachloromethane, which is used as solvent in a laundry industry. A molecule of butane contains carbon-carbon double bond, carbon-carbon single bond, carbon-carbon triple bond. So the answer is carbon-carbon double bond. A molecule of butane, because of the presence of double bond, it ends with ENA. The answer is carbon-carbon double bond. The process by which alkane reacts with halogen is called, alkanes react with halogen. What do you name it? Yes, what is the answer? Okay, I will agree that we have two options there that are correct. It's okay, no, hydrogenation is different, so we have only substitution, which is correct. I was thinking this is halogenation, but this is hydrogenation, so that's the reaction of hydrogen with alkane, but this is asking for alkane with halogen, so the right answer is substitution. Alkanes undergo substitution, alkenes undergo addition reaction. All organic compounds undergo combustion reaction. Okay. Which of the following compounds is saturated? Yes, which one has single bonds in it? If you look at the option carefully, you realize that the answer is cyclohexane. Ends with ANA. That means all the bonds there are single bonds. Butane, pentane, ethane are all unsaturated because they have presence of double bond in them. One of the products of combustion of propane in excess air is, yes, excess air. When you combust Organic compound, the presence of air, excess air, you are likely going to have carbon 4 oxide. But when you do it in limited air, your product will be carbon 2 oxide. For this question, your answer is carbon 4 oxide. The following compounds are hydrocarbons except, so which one are hydrocarbon except, so the answer is butanol. Others are hydrocarbons. Hydrocarbons is a compound consisting of carbon and hydrogen only, but butanol has oxygen, and so it is not only hydrogen and carbon only. So the answer is butanol. Which of these hydrocarbons will not undergo addition reaction? Which one will not undergo addition reaction? The only answer there that is correct is butane. Butane will not undergo addition reaction. Others will undergo substitution. Butane will undergo substitution. Others will undergo addition reaction because of the presence of unsaturation in them. Presence of unsaturation in them. Heptane will undergo the following reactions except heptane is an alkane. So what do you think the right answer will be? Okay, let's say addition reaction. Only alkenes undergo addition reaction. Alkenes undergo substitution reaction. Which of the following organic functional groups will likely decolorize ammoniacal silver nitrate? Yes, that we'll be looking at the difference between alkenes and alkynes, because alkenes and alkynes, to differentiate them, you need ammoniacal silver triosnitrate 5. So the right answer, the one that we know we decolorize ammoniacal silver nitrate, is an alkyne. Alkynes decolorizes ammoniacal silver nitrate. And even if you don't want to use the word decolorize, you can say it gives white precipitate with it. It gives white precipitate with it. What is the monomer unit of polyethylene? Polyethylene, polymerization is when you have two or more monomers coming together to give you polymer, which is a bigger compound. So the monomer is the smaller unit of the polymer. So for this question, the right answer is ethene. Ethene is the monomer unit of polyethylene. Polymerization is the joining together of simple molecules of the same kind or of different kinds called monomers to form a single complex long chain molecules called polymer. We have two types of polymerization. We have addition polymerization, and we also have condensation polymerization. Carbon atoms in alkenes are connected to each other by, so straightforward, the answer is double bond. They are combined, are connected to each other by a double bond. Okay, and that brings us to the end of the class. So can you count what you got? I hope you've done beautifully well. So put your hands together for yourself. That's beautiful. It was nice teaching you. It was nice reminding you what has been taught. And I wish you best of luck in the competition. Thank you.